In part A of this question, we're asked to find the centre of mass of the road sign from AE and AB, which means that all our measurements to the centre of mass will be taken from A for the two shapes and the centre of mass as a whole. In the first instance, let's set up a table just to record our results in, and the first thing we're probably going to look at is the area of the components of this shape. And we can see that we've got a square plus a triangle will equal the overall road sign. The area of the square, we can see, well, it's 6 by 6, so it's 6 centimeters squared. 6 times 6 is 36 centimeters squared. The triangle, a little bit more tricky. We can see we've got the two sloping sides and we've got the base of 6. If I drop a perpendicular in here, I note that it is isosceles, so this would be 3, splitting the base in half, and then I can immediately see that this must therefore be a 3, 4, 5 triangle, a Pythagorean triple. So that allows me to calculate the area of the whole triangle. Half the base is 3 times perpendicular height 4 has been 12 centimeters squared. Total area of the shape 48 centimeters squared. Now I need to find the centre of mass of each of the individual components of the road sign. So we'll put X and Y down. Now for the square, this is relatively straightforward. We can see from A we'd have to go 3 centimeters along the base and 3 centimeters up the vertical to get to the centre of mass, the centre of the square. For the triangle, we've got to remember that if we're moving from A, we've got to pass through the square just to get to the base of the triangle. For the X value, that's fairly straightforward. As I mentioned before, it's isosceles, so you drop a perpendicular down. You can see that you'd have to travel 3 centimeters along the base AB to get to the X part of the centre of mass. Then for the Y, you've got to remember that you must travel up the whole of the square, which is 6, and then obviously for an isosceles triangle, moving up that central vertical, you'd go a third of the way. Okay, so we'd have 6 plus 4 over 3, a third of 4. And obviously this equals X bar and this equals Y bar. So setting up our two equations to find X bar and Y bar, if we start with the X first of all, 36 times 3 plus 12 times 3 is equal to 48 X bar. So 108 plus 36 is equal to 48 X bar. 144 is equal to 48 X bar. Dividing, we can see that 3 centimeters must be equal to X bar. And from the diagram, it's fairly obvious to see that that central vertical from the top of D down will always cut the shape in half. So it has a line of symmetry, 3 in from AB. For Y bar, we can set up a similar equation. So we have 36 times 3 plus 12 plus times, I'm going to call this 22 over 3. That's the 6 plus 4 thirds, is equal to 48 Y bar. A little trickier sum to do. We've got 108 plus 88 is equal to 48 Y bar. So adding together we get 196 is equal to 48 Y bar. So 196 over 48 is equal to Y bar, and Y bar eventually comes out to be 4.083 centimeters. So there's your X and Y bar values.